Hello everyone. In last lecture, we have explored the powerful concept of object-oriented programming, including classes, objects, constructor, method, inheritance, method overriding, and encapsulation. These concepts helps us understand how to build structured, reusable, and efficient Python applications. However, there's an important question. What happens to the data after a program finishes executing? For example, suppose create a student management system and enter details of 100 students. If all data stored only in variables or sub objects, it will be lost as soon as the program ends. When you run the program again, you will have to enter all the information from the beginning. Similarly, imagine a banking system or a hospital management system or an e-commerce website. These applications deals with thousands or even millions of records. If the data disappears every time the data should be in the program closes, the application becomes useless. To solve this problem, Python provides file handling. File handling allows us to store permanently in file so that it can't be accessed, modified, or updated whenever required. But while working with files, another challenge may arise. Sometimes the file may not exist, the user may enter incorrect input, or the program may try to perform an invalid operation. These situations cause errors, and if they are not handled properly, the program may terminate unexpectedly. To make our programs more reliable and user friendly, Python provides exception handling. So, in this lecture, we are going to see the file handling, what is file, types of file, file operations, file opening modes, file methods, the with statement, then some practical programs on text, binary, and CSV files. Exception handling, types of error, what is exception handling, why exception handling is required, try block, except block, else block, finally block, rising exceptions, multiple exception handling, practicing the program. By the end of this lecture, you will understand how to store data permanently using files and how to handle runtime errors gracefully using exception handling. So without wasting time anymore, let's begin the lecture 8 by understanding the basics of file handling and exception handling in Python. File handling in Python. Introduction to file handling. So far, we have learned to store data in variable, list, tuple, dictionary, arrays, set, and object. However, all this data is stored in the computer main memory, that is RAM. When the program terminates, the data stored in RAM is lost. This means the information is temporary and cannot be used after again and again the program ends. To store data permanently, Python provides file handling. File handling allows us to create, read, write, update, and delete files stored on secondary storage devices such as hard disk or SSD. Using file handling, programs can save information permanently and retrieve it whenever required. Real life examples include student management system, banking system, hospital records, employee database, library management system. So, what is file? A file is a collection of related data stored permanently on a storage device. Files helps us to save information so that it can be accessed even after the program is closed. So example are student.txt, marks.csv, then employee.dat, report.pdf. So types of file. Python mainly works with two types of file. Three types of file. That is text file, store data in the form of characters. That is, it has the extension .txt. Then binary file. Binary file stores data in binary format, that is 0 and 1. The extension for binary file is .dat. So you can see the example here too. Advantages of file handling. Permanent storage, easy retrieval, data sharing, large data storage, easy backup, used in almost every application. So let me tell you the next concept in the file operations are Python supports 5 basic file operations, that is create, open, read, write and close. Then opening a file. Python uses open function. Syntax is file object is equal to open file name comma mode. Example, file is equal to open student.txt comma r. Parameters of open file name, that is the name of the file. So example, student.txt. Mode specifies how the file should be opened. File mode. First one, read mode. R is represented in read mode. Purpose. Read existing file. Error occurs if the file does not exist. So example is file is equal to open student.txt r. Then write mode. Write mode is represented by W. Purpose. Creates a new file if file already exists. Its old content is erased. Example. File is equal to open student.txt, comma W. Append mode. Append mode is represented by A. Purpose is adds data at the end of the file. Old data remains unchanged. Example. File is equal to open student.txt, A, comma A. Exclusive create mode. Exclusive create mode is defined by X. Purpose is creates a new file, raises an error if the file already exists. Example, file is equal to open student.txt, comma X. Read and write mode. Read and write mode represented by R plus. Read and write existing file. Then write and read mode is represented by W plus. Creates new file, allows reading and writing. Append and read mode. A plus, append data and read the file. Closing a file. After completing operations, close the file. The syntax is file.close. That is file name.close. Example, if you're opening a file name like this, that is file is equal to open student.txt, comma r. You have to close the file like file.close because the file name is file. Writing into a file. Python uses write function to write into a file. Syntax is file.write of data. So example, file is equal to open student.txt, comma w. File.write, welcome to Python. Then you have to close the file, that is file.close. Writing multiple lines. File is equal to open student.txt, comma w. File write Python, file dot write Java, file dot write C++, then file dot close. Reading a file. Python provides three methods: read, read line, then read lines. Reads entire file. Syntax file.read. Example, file is equal to open student.txt r. Print file.read, file.close. Then read line. Reads only one line. Example, file is equal to open file.student.txt r. From this file, the operator, that is file.readLine, will be only taking the first line from the file. Read lines. Read lines reads all lines into a list. Example, file is equal to open student.txt r. Print file.readlines, then file close. Appending data. Example, you can open a file with append mode, that is open student.txt, comma a. File.write machine learning, then file close. Then the extra content, that is machine learning, also will be printing together what the content was already present in the file. File pointer. Every file has a pointer initially beginning of file. After reading, pointer moves forward. Till function returns current pointer position. Example, file is equal to open student.txt, then r. Then print file.tell. Seek moves pointer to specified position. Syntax is file.seek of the position. Then example, file.seek of 0 moves pointer to the beginning. of the file. With statement, instead of closing file manually, Python provides with syntax with open student.txt r as file, print file.read. File automatically closes. Advantages of with automatic closing, cleaner code, prevents resource leakage, recommended approach, file methods. So students, you can see the all the methods which I have told you. Flush writes buffer data immediately. Difference between write and write lines. Write only one string, write lines writes multiple string. In write, there is only single line, but write lines have multiple line. Accepts as string, that is write, accepts as list, that is write lines. Okay. Advantages of file handling, permanent storage, data backup, easy retrieval, used in database, used in reports, used in applications. Disadvantages are slower than RAM, requires storage space, incorrect handling may lose data. So let me give the examples of text file, binary file, and CSV file. Before moving to the examples of text and binary file, let me give a small recap of CSV file. In addition to text and binary file, Python also supports another important file type that is called CSV. The full form of CSV is comma separated values. CSV files are one of the most commonly used file formats for storing and exchanging tabular data. They are simple, lightweight, and can be easily opened using spreadsheet application like Microsoft Excel, Google Sheets, and Library Office Calc. Whenever we need to store data in the form of rows and columns, CSV files are the best choice. So, what is CSV file? A CSV file, comma separated values file, is a text file that stores data in a tabular format, where each value is separated by comma. Each line in a CSV file represents one record, and comma separated values, the values are the columns. So, why do we use CSV files? CSV files are widely used because they store data in structured format. They are easy to read and write. They occupy less storage space. They can be opened in Excel. They are used for data exchange between different applications. They are commonly used in data science and machine learning. Advantages of CSV files. Simple and easy to understand, human readable format, easy to import and export. Supported by almost all programming languages, compatibly with Excel and Google Sheets. Faster than many other file formats. Disadvantages of CSV. No password protection, cannot store images, cannot store multiple sheets, does not support formulas like Excel, stores only plain format. CSV module. Python provides a built-in module called CSV to work with CSV files. Before using CSV files, we must import the CSV module. So the syntax is import CSV. Import function of CSV module, that is, the functions are csv.writer, creates a CSV writer object. Write row writes only one row into the CSV file. Write rows writes multiple rows. CSV.reader read data from a CSV file. Dict writer writes dictionary into CSV. Dict reader reads CSV data as dictionary. Then let me show the example of text file, binary file, and CSV file one by one. So let us start the example from text file. Write into a text file. So first of all, we have to open a file. That is, file is equal to open student dot txt comma. Also, you have to mention the read mode. Then file dot write welcome to Python. Then you have to give programming. Then you have to close the file, that is file dot close. Print. So I have given the code for you. Let me run it. F5. Here, the data written successfully is the output has been displayed successfully. Okay. See students, the output has been displayed successfully. So next moving to our next example for text file, that is read from a, let me change it, read from a text file. For that, file is equal to open student dot txt, comma, the mode is R. Then give data is equal to file dot read. Then print data. Then file dot close. Let us run it. Welcome to Python programming. So this is the output for the code. So let me display it. You can see the output here. So next moving to the third example in text file, that is to append data to a text file. So file is equal to open student dot txt, comma, it is in append mode. Then give file dot write backslash n machine learning. Then parenthesis close. Then file dot close. Then print data appended successfully. So F5. So data appended successfully. So the output is like data appended successfully. So let me show you the result. Okay. Now you have got an idea about text files. Then now moving to the second file, that is binary file. So note, binary file stores data in binary format. Python uses pickle module to store Python objects in binary files. For binary file handling, you have to import pickle module. So the syntax is import pickle. Let me show you an example, that is to write data into a binary file. For that, import pickle, then student is equal to Rahul, comma 101, comma Python. Then file is equal to open student.txt. Sorry, the extension is dat. Then comma the mode is wb, that is write with binary file. Then pickle dot dump. The dump function writes the student, that is the list, in the file, that the file name is file. Then file dot close. So let us run it. So here, this is the example to write data into a binary file. So second, that is read data in from a binary file. Same, the module import pickle should be imported. After that, file name, that is file open student.txt, sorry, dat. Then RB is the mode where write with binary. Then data is equal to pickle dot load. Load function reads the content from the file. Then print data. After printing, you can close the file, that is file dot close. Then F5. Then you can see the output by typing the whole function in the ideal cell. Then now an example, that is to store multiple student records. So import pickle, then students is equal to, here the list of lists are used, where Rahul, comma 101, then comma Anu, then 102, then list close. Then in next list we have to give Ravi, then his mark is 103. Then now, sorry, file is equal to open student.dat, comma, you have to give the method, that is write with binary, then close the parenthesis, then pickle dot dump students, comma file. Already you know that the dump method reads the content of the store, then file dot close, then print records saved. So let us run this code. So now the record has been added successfully. So you have got an idea about the binary file which I taught to write data into a binary file, read data from a binary file, store multiple. So now moving to CSV file. So CSV file stands for comma separated values. It is mainly used to store tabular data. So now let me give an example to understand CSV files. So opening the script mode and let me and one more thing, that is, if you are doing any program in CSV file, you have to import CSV module. So let us give the first example, that is write data into a CSV file. For that, import CSV file is equal to open student dot CSV, then W. That is the mode of the file opening. Then new line, sorry, new line is equal to, then writer is equal to CSV dot writer, the file name. Then writer dot write row. Here, this function writes a row of the details of the students. Then next, that is first one is ID, then name, then course, again writer dot write row, then Rohan. The first student name is Rohan. Sorry, his ID is 101. Then Rohan. Then course is Python. Next, again we have to enter another detail of another student. So let 102 comma Anu, then the course is Java. Then we have to close the file. So file dot close function should be called here. Then print CSV file created. That is F file. So like this, you have to write data into a CSV file. Second, read data from a CSV file. For that, you have to import CSV. Then file is equal to open student dot CSV, the extension for the CSV file, and the mode is R. Then reader is equal to CSV dot reader. Then the file name is passed as an argument. Then for R in reader print R. Then file dot close. Let us run this. So here you have got an idea about how to read data from a CSV file. Now the last example in CSV file, that is to append data to a CSV file. For that, you have to import CSV. Then file is equal to open students.csv. Then in append mode, you have to give new line is equal to, then writer is equal to CSV dot writer. Then the file name is passed as the then writer dot write row, that is passed as a that a list of a student detail is passed, that is sorry file dot close, then print data added successfully. So now students, you can understand the binary file, the CSV file clearly. So the summary is the extension of text file is .txt. So here no module is used. For binary, .dat or .bin is can be used for extension, and the module is to import is pickle. Then CSV file, the extension is .csv. the module which should be imported is CSV. So let me give some practice question and an viva question on file handling. Before that, let me give the advantages and disadvantages of CSV files. Advantages of CSV files. Simple and easy to understand, human readable format, easy to import and export data, supported by almost all programming languages, compatibly with Excel and Google Sheets, and faster than many other file formats. Disadvantages are store only plain text, do not support formulas like Excel, cannot store multiple sheets, cannot store images, no password protection. And the buyback questions for file handling, that is, what is file handling? What are text, binary, and CSV files? Explain open. Explain file modes. Difference between read line, and read lines. Explain tell and seek. What are the advantages of using statement? Then, what mode appends data? Then, why is the which statement recommended? So some are programming questions here. Create a text file and write data. Demonstrate, seek and tell. Count the number of lines, words and characters in a file. Then moving to little important questions. That is, write a program to display only the longest line in a file. Write a program to create a student record file using user input. Then write a program to copy the content of one file into another. So let me move to the next topic, that is exception handling in Python. Introduction. While writing Python programs, we may encounter different types of errors. Some errors occur because of incorrect syntax, while others happen during the execution of the program. If these errors are not handled properly, the program terminates immediately, leading to a poor user experience. To overcome this problem, Python provides a powerful mechanism called exception handling. Exception handling allows us to detect runtime errors and handle them gracefully without crashing the program. It enables the program to display meaningful errors and continue its execution whenever possible. In real-world applications such as banking systems, hospital management systems, ATM machines, and online shopping applications, exception handling plays a crucial role in making software reliable and user-friendly. So, what is an error? An error is a problem that occurs in a program and prevents it from executing correctly. Error may occur because of incorrect syntax, invalid operation, or incorrect user input. So, types of error. Python mainly has three types of error, that is syntax error definition. The type of error occurs when the rules, that is syntax of Python, are violated. These errors are detected before the program starts executing. Example, if true, print hello. So here syntax error because you have to give here the semicolon, but it is here missing. So it gives the syntax error. Explanation, the colon after if statement is missing. Then second, runtime error. Definition, that is, runtime error occurs while the program is running. The syntax is correct, but an invalid operation causes the program to stop. Example, A is equal to 10, B is equal to 0. Print A by B, that is A division B. Then here the error occurs, that is 0 division error. Division by 0. A number cannot be divided by 0. That is the explanation. Third, logical error. A logical error occurs when the program runs successfully but produces incorrect results. Example, length is equal to 10, breadth is equal to 5, where area is equal to length plus breadth, but the original formula is area is equal to length into breadth. So print area, it will be printing 15, but the correct output is 50. The formula should be used as multiplication instead of addition. What is exception? An exception is an unexpected event that occurs during program execution and interrupts the normal flow of the program.
In simple words, every exception is a runtime error, but not every runtime error needs to remain unhandled. Python allows us to handle these exceptions using exception handling. Why do we need exception handling? Without exception handling, program terminates immediately, remaining code is not executed, poor user experience. With exception handling, program does not crash. Display meaningful error messages. Continuous execution whenever possible. Makes software reliable. Common exception in Python. Let me explain. Exception here, this side is description. Zero division error, division by zero. Name error, variable which is not defined. Third, type error, that is invalid data type operation is entered. Value error when the invalid value is entered. Index error, list index out of the range is given. Key error, that is dictionary key not found. File not found error where the file does not exist. Attribute error, which is the invalid attribute that is has been called. Then import error, module not found, that is not imported to the function call. Exception handling keywords. Python provides 5 important keywords: try, except, else, finally, and rise. So now first with try block. The try block contains the code that may generate an exception. In an exception occurs, Python immediately transfers the control to the corresponding except block. Syntax, that is try, then risky code, then example, that try num is equal to 10, 0, then except block. So the except block catches and handles the exception generated inside the try block. So the syntax is try risky code, that is any statements of function or any program. Then except block. Then here the exception is handled. So here we have to give the exception handling code. Example, try num is equal to 10, 0. Where we have to give the in the except block that print cannot divide by 0. So number cannot be divided by 0. So the output will be the print statement here. Handling specific exceptions. Instead of handling every exceptions, we can handle specific exceptions. Example, try num is equal to 10 by 0, except zero division error, where the print statement gives division by zero is not allowed. Multiple except blocks. One try block can have multiple except block. Example, try num is equal to int of input of number, then print 10 divided by num, where except block has zero division error and print cannot divide by 0. Except value error, please enter only numbers. Else block. The else block executes only if no exception occurs. Syntax, try pass, except pass, else pass. This is the syntax. So students, remember the syntax for else block in exception handling. So try a is equal to 20, b is equal to 5, print a by b, and except block by zero division error, print division error. Else print division successful. The output is 4, then division is successful. Finally block. The definition, that is final block, executes whether an exception occurs or not. It is mainly used to release resources such as files and database connections. Syntax is try, pass, except pass, then finally pass. Also remember this syntax in your mind. Example, try print 10 divided by 0 except 0 division error and print cannot divide by 0. Finally block prints program ended. So output is cannot divide by 0. Then the program ended. Rise keyword. The rise keyword is used to generate an exception manually. Syntax, rise exception name message. So example, age is equal to int of input of enter age. If age less than 18, rise value error, age must be at least 18. Then print eligible. So complete example is here. Let me explain. Here try block is given. Next we have got the input. Then we have given the print statement. In that we have divided the 100 by what the user is being given, that is num. Then we are accepting the value error, that is print only the valid integer. So here we should not give floating point number. If floating point number is given, then it will raise the value error. Except second except block contains zero division error. Here we should not give 0 as the second num. So the output will be like division by 0 is not possible or not allowed. Else block print the operation successful. So if these two cases is not run successfully, it comes to the else part and prints the operation successfully. Then finally also prints that is thank you. Flow of execution. Start, try block, exception, yes, then except block, then finally, then end. If no exception, try, else finally, to and to the end. Advantages of exception handling: prevents program termination, improves user experience, makes software reliable, simplifies the debugging, maintain normal program flow, handles unexpected situations. Disadvantages are slight performance overhead, improve handling may hide actual bugs, excessive use make codes too difficult to understand. The real life examples of exception handling are ATM machines, banking systems, login systems, file handling, online payment gateways, hospital management, data applications, and web applications. So, best practices: cat specific exception, use finally to release resources. Avoid empty except blocks. Display meaningful error messages. Use rise only when necessary. So next, difference between error and exception. Error stops the program where exception can be handled. Error usually unrecoverable. Then exception is recoverable. Then, example, in error we have syntax error. For exception, we have zero division error. Difference between the syntax error and runtime error. Syntax error occurs before execution. Runtime error occurs during execution. Syntax error program does not start. Runtime error program starts but crashes. Syntax error detected by interpreter. Runtime error detected while running. So some of the while questions of exception handling. What is a exception? What is exception handling? Why do we use exception handling? What are the three types of errors? What is the purpose of try block? What is the purpose of except block? What is the else block? Does finally executes always? What is the use of rise? What is the difference between an error and an exception? So some of the interview questions. Explain exception handling with an example. Difference between try and except. Difference between else and finally. Explain rise keyword. What happens if there is no except block? Can a try block have multiple except blocks? Can we use try without finally? Can finally execute after return? Why is exception handling important? Give real-time applications of exception handling. So let me give some of the programs as an example. So let me give two beginner friendly examples that you can understand very well. So let us move to the ideally shell script mode. Then first handling zero division error. First try num1 is equal to int of input of enter first number. Then num2 is equal to int of input of enter the enter second number. Then give the colon and quotation close. Then result is equal to num1 divided by num2. Then print result is to then quotation close. Then result. Then in except block, you have to give zero division error. Then print error division by 0 is not allowed. So here F5, sorry F5. So it is 2. Then again F5. Enter 52. Here the error is displayed as it is the zero division error. So let me show the output for you. See, the output is like zero division as error is found here. So next, moving to the statement that may cause an exception are placed inside the try block. If user enters 0 as the second number, Python raises a zero division error. The except block catches the exception and display a user-friendly error message instead of terminating the program. So moving to the next example, that is handling value error. So let us move to the script mode in ideally shell. Here, try age is equal to int of input of sorry input of enter your age. Then print your age is sorry age. Then accept value error. Then print error. Please enter a valid integer. So now let us run the code. So see students, the output is I entered my age. So it is printing your age is 18. So let me show you in the ideally shell. So here is the output you can see very well. The int function converts the user input into an integer. If user enters a non-numeric value such as 20, Python erases a value error. The except block catches the exception and display an appropriate error message. Let me also run one more time. Let me enter another time. That is 20.5. So it will give the error during error handling of the above exception. So let me show you the output. So see students, if we give a decimal value, so it will give the error rising. So here you have got an idea about exception handling with many examples and you have to practice many more questions. For that, you have to import CSV. Then file is equal to open students.csv. Then in append mode, you have to give new line is equal to, then writer is equal to CSV dot writer. Then the file name is passed as the then writer dot write row, that is passed as a that list of a student detail is passed, that is sorry file dot close, then print data added successfully. So now students, you can understand the CSV file clearly. So the summary is the extension of text file is .txt. So here no module is used. For binary, .dat or .bin is can be used for extension, and the module is to import is pickle. Then CSV file, the extension is .csv. The module which should be imported is CSV. So let me give some practice question and an viva question on file handling. Before concluding this lecture, here are some practice questions for you. Try to solve them on your own mind without referring the notes. The theory questions are: what is the file handling question? What is the difference between text file, binary file, and CSV file? So, what are the different file opening methods in file handling available in Python? What are the different types of errors in Python? Explain the purpose of try, except, else, and final block. What is the difference between an error and exception? Then, what purpose of dump and loader used in binary file? Then some programming questions here are: write a program to append new data to an existing text file. Write a program to find the value error using exception handling. Write a program to raise a custom exception using the raise keyword. Then moving upon to the next content. Thank you so much for watching the lecture 8 of our Python full course. In this lecture, we have learned two essential topics in Python programming, that is file handling and exception handling. We started by understanding file handling, which allows us to store data permanently instead of keeping it only in memory. We learned about different types of files, that is text file, binary file, and CSV files, and explored how to create, open, read, write, append, and close files. We have discussed many functions, that is read, write, seek, tell, dump, load in the different types of file. Advantages of using this with statement for safe and efficient file handling. Next, we have moved to exception handling, which helps us to manage runtime errors gracefully. Without terminating the program, we understood the types of errors, the concept of exception, and how to use try, except, else, final, and raise statements to build robust and reliable applications. These concepts are fundamental for developing real-world Python applications because they help us to store data securely and make our programs more reliable, user-friendly. and error resistant. Make your own practice all the examples and solve the practice questions to strengthen your understanding before moving on to the next step. If you found this lecture helpful, please like the video, share it with your friends, and subscribe to the channel so you don't miss the upcoming lectures. In the next lecture, we will continue our Python journey by learning modules and packages in Python. So, until then, keep practicing, keep learning, keep coding. Thank you, and I will see you in the next lecture. And remember, learning programming does not end with watching videos. The key to become a good programmer is practice, curiosity, and continuous learning. So keep solving problems and build your own projects and never stop exploring new technologies. I would like to thank each and every one of you for your support, encouragement, and valuable feedback through this journey. Your love and motivation have inspired me to create more content for you. This may be the end of our Python course, but it's just beginning of your programming journey. So thank you once again for learning with me. Wishing you all the best for your future and studies, placement, interviews, and future careers. Take care, stay curious, and always be happy. So this is Ashwin entirely signing off from this Python course programming lectures. Happy coding!